My name is Spencer Crum. I work at HP. I do primarily OpenStack related stuff, and a lot of that touches Puppet. Not setting up OpenStack with Puppet, but we use Puppet to configure the CI system that we use, both internally at HP and upstream in the open source OpenStack world. It's really exciting for me to be here at OMSI. OMSI has been I'm an Oregon native, so OMSI has been a piece of me since I was 6 or 7 years old. Science is really cool. I'm not sure if there'll be time, but for any of you who haven't done it, the games at OMSI are just as fun and frustrating for adults as they are for children. I feel like I need to talk a little bit about OMSI. It's the Oregon Museum of Science and Industry. It's unfortunately closed today. I showed up a little bit late, and as I was coming forward, this 7-year-old boy, or maybe 6, with his sister 2 steps behind, was running at a breakneck pace, yelling OMSI at the top of his lungs, as mom kind of struggled along, like, come on, kids. And they got to the door, and then it was closed. And it was just so sad. So if you could find it in your hearts to donate a little bit to OMSI, it's probably worth it. So I want to tell a story about science. For my personal experience. So in the 6th grade, I don't know what happened. I might have been in trouble, but I was in my 6th grade science class after school ended. And I don't know how I managed to say it, but I managed to assert that a heavier object will fall faster than a lighter object, which is not true. And my science teacher was like, what? No, and he went and he found the other science teacher. So this 6th grade science teacher and this 8th grade science teacher, they hold up a ping pong ball and a bowling ball, and they drop them at the same time, and they hit the ground at the same time, and my mind was blown. And I was a science person from there on in. And it took me a while to realize why they were so excited about showing me that experiment. I mean, they showed me 10 experiments, 15 experiments over the course of the year, but that experiment was one of the most important experiments ever done by Galileo. And it was one of the first times in the second scientific revolution that original theories put forth by the Greeks were rejected. So that's all very big and important. And Hiera is actually relatively unimportant compared to that. Okay, so I work at HP Helion, which is our cloud offering. Yay! We are hiring like crazy. HP is one of those companies that's bigger than like a lot of nation states. So we probably have job recs for everyone in this room. If you want. I work particularly in OpenStack. There's a lot of OpenStack jobs. Course. Oh yeah. All right, I wrote this book, or I wrote the 2nd edition of this book with some friends. There's a 3rd edition on the way. Somebody said that the books are out to date. This one is pretty close to up to date. I will point out that we have an errata on GitHub for all the problems that we missed and stuff like that. If you have a copy of this book, I'd be happy to sign it. This is the word cloud. If you're not real unless you have a word cloud, I hear. This is the word cloud from our book. I particularly like the word certificate. Yay, security. I work primarily with open source Puppet. So most of the things you're going to hear me talking about is from an open source perspective. There are enterprise components that I don't have a whole lot of experience with. But everything I'm going to say in this talk, for the most part, because it's very beginner and very intro, is going to be just as applicable to the open source product as it is to the enterprise product. So the agenda is to talk about what Hiera is. We're going to talk about what Hiera isn't. We're going to talk about the architecture and how it fits in the Puppet architecture. We're going to go through a couple basic examples. We're going to go through some configuration, like if you're a sysadmin. Some of you might be. We're going to look at a more complicated example. And we're going to talk about kind of some of the places people stumble, the new users stumble. Okay, so at its most fundamental level, Hiera is software by Puppet Labs. It was started in 2011. It started out as a plugin, but is now fully in the core. So if you install any modern version of Puppet, you have Hiera out of the box. It's just working. However, it's sometimes nice to remember its origin is a plugin. And then what it really does is it's a way to plug data into your module and to get this separation of concerns between data and configuration. And why do we want that? Well, we have all these servers, and we want them all to be the same. Except we actually want some of them to be different. And so the example there is like you have machines in a PDX data center, and you have machines in a Seattle data center. And the Seattle data center and the PDX data centers need to have different DNS servers configured in Resolve.conf. And that's just the way it is. There's another difference that you might have. You might have a temporal difference. So in January, you have 14 people working at your company, and you want them all to have users on the servers. But then in February, 2 of them have left, and 4 new people have joined. And you'd like that state to be asserted on the server. And Puppet's good at this, but what we're talking about is changing data. Little bits of data, not changing the Puppet code itself. Another major advantage of separating your concerns between your data and your code is that both get better when they're independent. So your code, when it no longer has a lot of site-specific data in it, is easier to share, it's easier to test, it's easier to read, it's easier to modify. Similarly, your code, once your code is extracted out of ERB templates or hard-coded into Puppet manifests or wherever it is right now, once your data is there, it can be interacted with by other machines. It's digestible, it's mutable, it's readable, it's auditable, and there's something else on that card. So Hiera, at the end of the day, what Hiera does is exposes this Hiera function, which is a key value lookup function. So you're going to say, var equals Hiera lookup on some string. And it'll do just a lookup. And it's a globally available lookup. And that function is available anywhere in your Puppet manifests. And what it looks up is actually pluggable. It's not correct to think of Hiera as a data store. Hiera is more of a router or a shim in front of another data store. And that's very pluggable, and everyone's written basically everything you can think of from etcd to MongoDB to YAML files as a backend for Hiera. It's also noticing, because I know there's a lot of beginners in the audience, that Hiera is separate from PuppetDB. PuppetDB and Hiera are easy to confuse because they're both data stores. They're both database-like. So when do I use one, when do I use the other? Where do I put my data? Is a very valid question. And the way I like to present this is to talk about the difference between etc and var on a Unix system. So on etc, you have a lot of information that's been set by the administrator, and it doesn't change that much. In var, you have log files and libvirt images and Postgres databases and stuff. So those are data files that are being written out by daemons and then read in by daemons. So an example is when a Puppet client runs, it'll run factor, and then put those facts into PuppetDB. And then another application like your web dashboard will read those facts out of PuppetDB and display them to you. An example of Hiera is writing your resolve.conf into Hiera, and then it'll be pulled out and thrown in etc by Puppet. So let's look at the Hiera architecture a little bit. And we can't really talk about the Hiera architecture without talking about where it fits in the Puppet architecture. So this is your standard 2-node Puppet architecture, right? And of course, agents can scale to n agents, but you still have this idea of agent-master interaction. So the agent fires up, it collects facts, it sends the facts over to the master. The master thinks about those facts and produces the configuration object called the catalog, ships it back over to the agent, and the agent runs. And this is great, but the problem is that it's a closed system. There's no way for us to change the agent without changing the master. So what Hiera does is Hiera sneaks in there and provides another data input to the master. So the agent still fires up, it collects facts, it gives them to the master. The master takes those facts, combines them with lookups from Hiera, creates a new configuration object and sends it in. And there's some real advantages to this open system. The first is, there's 3 advantages I want to talk about. The first is that it's safer and it's lower friction. So changing the code that's running on that master is relatively easy. It is much easier than running a shell script on every server. But ultimately, what we're talking about doing is changing the directory with code in it to a different, or the same directory with different code in it. And that's done through kind of traditional Unix utilities, like your CP and your move and your git clone and your copy modules from the forge and your SSH loops and all these things. And those are racy. They're error prone. They take time. And when you look at a tool like R10K, its very existence and popularity underscores the idea that there are consistency and speed problems with updating the Puppet master's Puppet repository every time you want to make a change. Whereas if you have a Hiera database backend, right, you're using, say, something like MySQL, making a change is very easy to do. You can put a REST API in front of it, you get transactions, you get rollbacks. It's very low friction, and you have greater confidence that your change will succeed. You can even use constraints on your database to make sure that data that you put in is of the correct format. The second advantage is machine drivable. I think probably about maybe 35% through your journey from Puppet beginner to Puppet expert, you try to add Puppet changes to some deployment pipeline. And when you have to make a git change and modify code directly in that, it really screws up that attempt. So now, whatever you have, whether it's a pipeline or a Jenkins job or a Jira ticket or chat ops or whatever you have, you can simply write into that database or write into an API that is a thin shim on top of that database. The third advantage it provides is secret storage. So we don't really want to keep our secrets, our root passwords, our MySQL passwords in the same Git repository that we keep our Puppet code in. It's just not where that goes. And so this gives us an opportunity to put the secrets somewhere else. And I haven't really explained this yet, but Hiera supports multiple backends. And one of the things I've seen many times is running 2 backends, one for secret storage and one for general data storage. So let's talk about if you're a system administrator and you're setting up the Hiera system. As I said, there's multiple backends. What we basically always recommend is that you start with the YAML backend, which is not an exciting backend. It is the mayonnaise of data. But it is easy to get started with. Everyone else is already using it. You will hit less bugs and get further in your kind of exploration if you use the YAML backend. So it's great for demos. The first thing is that Hiera ships with 2 config files. One is etc-hiera.yaml and one is etc-puppet-hiera.yaml. And they're used during different parts, but if you symlink them together, you will never have a problem. So if you look inside Hiera's configuration file, which is in YAML, I really just want you to look at the top 2 stanzas of this. So it says that our backend that we've configured is YAML. That's where you would write another configuration, like another backend, like JSON or MongoDB or whatever. And then it has the configurations for that backend, in this case, the directory under which the YAML files are stored. Finally, we can look at what the file structure in that data directory looks like. And so that looks, there's some specifics here, but mostly I want you to look at this common.yaml. So if you think of Hiera, that Hiera function, as being a globally available lookup, key value lookup, and you just want to put the same key for everybody, that common.yaml is where you put it. You just say, foo equals bar, and anybody can look up foo and get bar out. And there's some complexity with this other stuff, but for right now, all you need to know is that. So to review a little bit, Hiera is a place to put your data. It's back-end driven, and it exposes itself as a function call to look up keys. So I want to jump into some examples, some very basic examples. So this is Puppet code to configure some Jenkins slave. The Jenkins slave needs to be SSH'd into by the Jenkins master because it's a dumb slave. And we have to configure that key. And so in kind of bad Puppet code, we just hard code the public key in and it gets it done. And we can change this pretty trivially. We go to common.yaml and we add a global key and we add that Jenkins key equals SSH public key. I hope it's relatively obvious that I've abbreviated it. Hiera-D is the debugging tool, essentially. Or, there are a couple, but this is the command line Hiera, which allows you on the server that runs Hiera in the YAML backend or any other backend to manually perform lookups before you involve Puppet in the process while you're developing and debugging. And you can see that it dumps out the correct key. And that means we can refactor the code like this. And there's a couple different ways to refactor this code, it's worth noting. But this one is relatively easy to follow. There are a couple places, and this is kind of one of them, where you can count on implicit Hiera lookups. But at a beginner level, there's no reason to focus on that. Here we have not public data, but secret data. So we have this MySQL password we don't want in our Puppet manifest anymore. We'd like it to go somewhere else. So we put another key in common.yaml. We verify that the key is available through the Hiera debugging tool. And then we refactor the code much the same way. Okay, this is a great place to stop and ask any questions if you have any.
Hiera debugging tool.
Hiera debugging tool is perhaps over generous. It's just calling Hiera on the command line, and the -D shows you what it's doing, debug. And that's actually really useful because what it's going to do is it's saying in YAML backend. So when you have multiple backends configured, you'll get the information that you need there. And if you have a more complicated hierarchy than jumping directly to common.yaml, you'll see that as well. Found in common. And that'll become relevant later. Yes?
Does Hiera data pass through to your facts coming from factor?
So the question was, does Hiera data pass through to your facts coming from factor? I don't understand that question.
Like if you look at the facts of the system, will you see the variables that are
Okay, so if you're on a machine and you type factor-p, will you see things that are done by Hiera lookup? The answer is no. Hiera lookup, if we jump all the way back, what really happens is the agent connects to the master, and the master does its own loop with Hiera, which generates the configuration catalog and sends it over. And once you have that configuration catalog, you can't see the code and you can't see the lookups anymore. It's all been cloaked. Great question. Yeah?
What can we do to secure the Hiera backend for encryption so it's not stolen in the lockdown?
So the beauty of the architecture is that Hiera doesn't care. So whatever your security compliance needs are, Hiera is just going to look up in however you've configured it to look up something. So that could be a REST call, it could be decrypt something with a GPG key, something more complicated than that. It's just a shim. And the reality is that the Hiera backend is like 100 lines of Ruby, and it's super easy to write, and there's tons of examples. So you can, even someone who doesn't know Ruby like me can just kind of beat my head against it until it works. That's how the LDAP backend works. Yeah?
Can we quickly pause for like half a second on the lookup part where the code actually looks up the backend? I missed that.
Okay. Well, this is actually probably the slide we want to be on. So in a typical model, your agent calls into the master, and the master takes in as inputs two things. It takes facts, and it takes the Puppet code that you wrote, your Puppet manifests, right? In this model with Hiera, there are holes in those Puppet manifests that say, go do this key value lookup. Puppet transparently uses Hiera to perform those lookups, and then replaces where it says $var equals Hiera lookup key with variable name, or with a variable name equals string. And so you see that in the examples. So we have $SSH key here, and we're setting that variable here because this gets expanded out to a string. And it's worth noting that Hiera can do kind of your 3 JSON-y data types. It can do like strings, which are kind of like numbers in Puppet. It can do arrays, and it can do hashes. Are there any other questions? Yeah?
So where do you differentiate between, say, environments? Like if I have SSH keys, I want to have different ones for test and for production.
And that's what we'll talk about right after we're done with this question. So we're doing a knowledge check first. Okay, anyone else? All right. Okay, so now we have a situation like this. And in this situation, we have a Graphite class. In order to install Graphite, you have to basically build it from source if you're doing it correctly. In order to build it from source, you need to have kind of the development toolchain. And so the list of packages you need to have installed is different on Red Hat systems and Ubuntu systems. And so we have this packages variable and this big gross if statement. And what we want to do is use Hiera so that it's not so gross. And this is a bit of a contrived example, but I'm sure you guys can all see, or you all, gender neutral, can see what to do with it. Hiera stands for hierarchical data store. So it's a hierarchy that's fact aware. And it provides defaults and overrides. So let me tell you a story about when I was about, I don't know, 14 or so. My mom has an office at home. She's a very busy woman. So the phone would ring and I would answer the phone and I'd be like, hello. And they'd be like, I want to talk to your mom, Spencer. And I'd go to my mom and be like, somebody wants to talk to you. And she's like, who is it? And I'd be like, it's so-and-so. And she's like, I'm not here. Or if it's your sister. She's like, all right, I'm here, fine. But the question, the point of that story is she's saying, Who's asking? So what Hiera provides is this global lookup variable, this var equals Hiera lookup. But when that lookup is being performed, it can use fact to slice and dice and differentiate between different machines. And it can use facts, and it can use environments, and it can use variable set that are available in the scope when the lookup is performed. And so what that means is that if we come back here, we kind of see what we're going. Instead of using this OS family up here, what we can do is we can say packages equals Hiera lookup, and Hiera will identify the OS family, and from that identify the package list, put it in the variable, and our public code becomes much cleaner. So let's look at what that looks like. All right, remember this file? I told you not to look at the bottom. We're looking at the bottom now. So this is a hierarchy, and it's essentially a lookup list. It's top to bottom, and it first, whenever it performs a lookup, it first tries, the top thing, and if it's unable to find the key in that data block, essentially, it falls down to the next one and attempts to look up. And while expanding these variables, client cert is how you identify a name of a node. OS family is how you identify the, generally speaking, group that the operating system involves or reports as. So for instance, CentOS 6 reports its OS family as Red Hat. And Debian Mint, or Ubuntu Mint, reports OS family as Debian. Yeah?
Stupid question, but why is it a percent instead of a dollar sign?
Stupid question. Why is it percent instead of a dollar sign? And the answer is yes. The variable expansion inside of, I think there are at least a few competing systems for variable expansion inside YAML, and this is the one we have. Good question. This is the kind of thing that you don't need to really think about, right? You're going to copy from my slides. You're going to copy from blog posts on puppet.com, and there'll be a few nerds who get super excited about this, but you're just going to use it, okay? Okay, so what it's going to do is it's going to look up in this file, and if it doesn't find it, it'll look it up in that file, and if it doesn't find it, it'll look it up in common. And that means that if we can set a default SSH key or a default package list in common, and then set an override in OS family common. So we could have, if this set environments, and we probably should have set environments, we could have Jenkins key set to one thing in common for everybody, and then an environment-specific override. So if you look at the Hiera data, this starts to make a little more sense. It's going to expand OS family. It's going to find Red Hat. It's going to jump to common.yaml. And then this thing which you all kind of remember. So that's what common.yaml looks like for the Debian section. It's these three packages. And that's the YAML shorthand for an array. Similarly, we have kind of the same thing in Red Hat. And we can, again, use the Hiera lookup tool. And when you want to tell, somebody asked if it's factor aware. It's absolutely factor aware. It's kind of the whole point. So you could set facts by this kind of key value syntax at the end of your Hiera command line lookup, and it'll pop right out. Similarly, if you set your OS family to be Debian, it'll pop right out. And this is important. When you unset it, right? If the lookup will fail, it will provide nil on the command line, and it will abort catalog compilation on the master. And that might sound scary, but honestly, best practice in Puppet is to open your case statements and specifically call out the things you are able to handle, and in the default case, to fail. And that way you fail at catalog compilation time, which happens on the master before any changes have been made on the agent, so that the agent isn't in a corrupted, strange state that you then have to debug. So let's look at what this looks like. So it started out looking like this, and now it looks like that. It just grabs the packages out of Hiera, and it puts them into this, it just throws them into the package resource. You notice we didn't even have the package resource written here. I just kind of left it as an exercise to the reader to figure out what was down here. I mean, most people probably figured it out. There was a package resource down here, but there wasn't room on the slide, and now there is. Somebody probably wants to ask me about this key. This key is a little funky looking. This key is a little funky looking. And the reality is that that key does have special meaning for advanced users. For general users, you can use whatever key you want. So there are a lot of backends. I want to call a few of them out. YAML and JSON are the ways to get started. Absolutely. They're used by people at all levels of skill. File and LDAP are the ones I personally have helped contribute to. The file is exceptionally useful because you can grab an entire file without passing through a string. So you can say in a file resource, you can say file etc apache webserver.pem or webserver-cert.pem. And then you say content equals Hiera lookup on key. And that way you can keep all your SSL certificates as plain files in your directory somewhere, as opposed to having to transcode them into YAML or put them into a database. GPG and EYAML are, EYAML stands for encrypted YAML, and they're both backends that enable, for instance, you can, it's a little funky because somebody has to be able to decrypt it, but you can store them in an encrypted mode, and then the puppet master or the YAML or the Hiera server can hold the key to perform that decryption on the fly. And that satisfies certain requirements for having it encrypted on disk and such. And then there's your real databases, your Postgres, your MySQL, your Redis, and not your Mongo. There's totally a Mongo backend. So what are the pros of this? Well, as I've harped on many times, the separation between data and code helps both of those individual components evolve and get better on their own when separated from the other. Distance truly does make the heart grow stronger. Secret storage, now there's a real pattern for secret storage in Puppet. You don't have a monolithic Puppet repo that has a lot of code in it, a lot of shell scripts, and a lot of secrets in it all at the same time. You can now share your Puppet code with just about anybody in the organization. You have a lot of backends. Probably if you already have some kind of a network database or a configuration management database or something, it's pretty trivial, as long as your other thing has some kind of an API, to just directly look up in that. Some of the conditional logic that we had in our Puppet code that was kind of mucking things up is now pushed to a different layer. And our Puppet code looks better because of it. There are some cons. So it's hard. It can be hard to figure out where things are coming from. Just because you're looking up a key on a value with that hierarchy, it can be difficult to debug what has happened. The Hiera YAML can't support two separate directories right now. It can't look up, you can't have a directory of secrets and then a directory of more normal data. Not well anyways. Debugging, again, is really painful. There's that Hiera-D command that I showed you. And Fried Bob is working on something called the Octo something Ninja, which is a tool in Bash, like very advanced Bash, that helps Hiera debugging. And there's still kind of, it's unclear exactly what the role between public modules available on the Forge and Hiera data is. But Ari, who is actually the writer of Hiera originally, has written something called Puppet Module Data, which is one of a couple different attempts, but this is probably the best one, to bring Hiera data into public modules. So what are the issues some users have? Complicated hierarchy. It is really easy to make a really complicated hierarchy and then be undebuggable. So my recommendation to you is to start simple. Runaway backends. So it's worth noting that it's fun to plug a lot of backends in, but it can be confusing again because you now are walking down two arrays. You're walking down your hierarchy in one direction and your backends in another direction. And it can be, again, confusing where things are being pulled from. Latency and load is a real problem too. So for every element in your hierarchy, and then for every one of those, every backend you have, and then for every one of those, every key lookup you do, you pay the price. Excuse me. You pay the price of whatever network time or file operation time it takes to do that. So it is pretty easy to slow down. It's pretty easy to slow down your Puppet manifests or your Puppet catalog compilation time if you're not careful. And so there's some obvious ways to make this better. One is don't get super complicated and fancy. The other is to make the fast lookups that you're doing a lot fast by putting them high up in the hierarchy or rearranging your backend so that the one that has most of the data gets looked up first. Finally, there's architecture. So I'm not telling you how to structure your code base in this talk. I'm not telling you where to do your Hiera lookups. But on a general sense, you probably want to pick something and then do it. So you might want to do all your Hiera lookups in site.pp. Or you might want to do all your Hiera lookups at the last possible second. But you probably don't want to mix the two. And that's something to keep in mind as you sort of tinker with this. So I want to end on a positive note, because I ended on my cons otherwise. So use Hiera, it's freaking awesome. Everybody who knows what they're doing in Puppet land is using Hiera. And people who really know what they're doing are constantly finding new cool tricks that it provides. It's actually one of the most innovative things in Puppet. It's not well represented in any other tool. And for more complicated tasks like setting up OpenStack, the tooling and the technology and the workflow that Hiera enables is phenomenal. Start with the YAML one. I said that like 4 times this talk, but I'm going to say it again. When you hop in IRC, you hop on ask.puppelabs in the mailing list with a problem, and you're using the YAML backend, you're just going to get more responses. More people have already seen that problem. There's also a built-in concept of this hierarchical lookups, and the directory structure that you can use in the Hiera, or in the YAML backend to Hiera, well models to that. Getting that to be well modeled in a MySQL database, if you're not like a DB architect, is going to be a little harder. Your Postgres and your MySQLs and such are much better suited to the global lookup table. And try and experiment and iterate and be afraid to don't be afraid to make a little testing branch and kick some stuff into Hiera and pull it out of Hiera and pull something into Hiera. You'll be surprised how fun this is. All right, any questions? Yeah.
You had mentioned watching for doing multiple backends. Earlier you mentioned when you're using just YAML as a top-down read, do the multiple backends run simultaneously, so you have race conditions, or does it do it in, or with the decision?
Okay, the question was, when using multiple backends, what's the order of operations between the interaction between multiple backends and multiple hierarchies? And someone should probably check me on this. But as I understand it, it will run your first backend and will run everything in the hierarchy. And then it will run the second backend and everything in the hierarchy, and the third backend and everything in the hierarchy. There was a pull request to make that configurable, and I think it stalled out. So that you could invert it, so that you try the first level of the hierarchy against every backend, and then. Great question. Yeah.
You didn't show them the default value at the end. That's kind of a neat option.
Yeah. All right. So. So you have this line, this packages equals Hiera lookup value, and if it can't find anything in Graphite packages, it will fail a catalog compilation. But what you can do is you can put a comma right there, and then a string or a hash or an array or whatever, and it will, if the Hiera lookup fails, it will use that default value. So that's a way to, that's definitely a good way to get started, because then you're not having catalog compilation failures every time. However, again, with Puppet, what you want to be doing is asserting state, and being assertive with your data follows that model. So if you want to have a default override that everyone gets, you can put it in common.yaml. But if you put it in here, now you have more and more people. So this is where architecture comes into it. Either you put all the defaults in common.yaml so that if there's nothing specific about them, common.yaml will provide, or you put all your defaults in here. But if you start mixing and matching, it will be very confusing for people trying to read your code. Yeah, or at the top.
There was a mention earlier today about recursive Hiera lookups. Can you speak to that a little bit?
Okay, yeah. So I don't really have an example that's complicated enough to show it, but you could imagine that you look up a string and you put a string in password, and then you do a Hiera lookup on password, and so on and so forth, until you've created a lot of back and forth between your you and your Hiera backends. Does that answer your question?
Is there, it seems like a useful tool. Is there a rule of thumb as to how far you can go before it's a problem?
Well, what's your experience level with Hiera?
Beginner.
I would say don't. There are lots of things you can do with Hiera. It is the single biggest thing to shoot your foot off with in terms of building complex code that no one else can read. So my advice would be to be, while I'm telling you to try stuff, and absolutely try stuff, use caution and respect the idea that the complexity here ramps up very quickly. But that being said, some of the smartest people I know use recursive Hiera lookups. And they actually fill out they do Hiera lookups in here, or in here. I've seen people call because you can use Puppet functions in here because lols. You can actually use Hiera lookups here, which is just mind-blowing. So yeah, absolutely experiment with it. I don't have a specific use case because I try to keep it simple. There was somebody in front of you a little bit.
You didn't mention data bindings at all, and I was wondering if that was out of simplicity or if you have a personal opinion on it.
I do have a personal specific. Okay, so all right. I need to jump. Okay. So you see this Hiera lookup? You see how this funny key is? What Carl was talking about is called data bindings, and there is an implicit lookup in Puppet where if a class called Graphite takes a parameter called packages, and the key is called Graphite : packages, it will do an implicit lookup on that key and populate it. Now, I personally hate this because it's super hard to tell what's going on, but other people love it. And as your complexity rises, it's actually very useful. I will admit that at high levels, or where you're doing really fancy stuff, it actually makes the code cleaner. There's also no reason you can't simply make the default argument to the class the Hiera function call. And I can't comment on any performance benefits or detractors of that. Somebody up there.
Perhaps I misunderstood, but you implied something about Hiera support in Forge modules being kind of an open issue or undefined. What kind of issues might we run into with trying to use Forge modules and specify parameters for them with Hiera data?
So the direction that you're talking, okay, so the question was, given, I made a comment that Forge modules and Hiera are not, their interaction is not well defined at this point. And the question was, what kind of problems will I experience when I'm trying to use Hiera to populate values in a Forge module? And the answer to that question is very little. The direction of a consumer of a module using Hiera is very well established. You simply use the module. And if you want to populate the values with hierarchies or use implicit data bindings, that's fine. But if you're a module author and you would like to use Hiera to put, you have a lot of data in your module for whatever reason, and you'd like to put it in Hiera, that's not well understood right now. So as a user of a module using Hiera, you'll probably be fine. I got a question up there.
Yeah, as a developer task, how would I overwrite the precedence of a backend for testing?
There's a third argument
okay.
that takes precedence. I think that's just in the hierarchy. That's just in the hierarchy, I think. But it's really easy to use Hiera-C myconfig file if you really want to get fancy with changing the behavior of the config file before you roll your site, basically.
But it is done in files? The backend is always specified in a file?
Yeah, the question was, is the backend always specified in the files? And the answer is yes. And the question at the beginning, I don't think I repeated it, was, as a developer, how do I kind of quickly mock or how do I quickly prototype, or how do I quickly evaluate what would happen with a different backend or a different order of backends? Great question, yeah. Yeah?
Do you have any comments on how to architect or structure code so that it's resilient against backend availability? So say you're sourcing data from a MySQL database, and for some reason that database is offline. I don't want all my Puppet nodes to start running agent runs and start blowing up and reconfigure anything so they can't reach that and it's going to some other default.
So the question is, how do you make a protective stance in the event of a network or an event of disruption where your backend is not available? And the answer is largely you play defensive baseball. And you make sure that you do a lookup, and if that lookup doesn't return something exactly good, you just fail catalog compilation. And I think if I do remember, the catalog compilation is performed on the master before the agent is even touched. So it's always safe to fail catalog compilation on the master, and your agent will remain in the state it was when it ran factor. There's a question up there somewhere.
Yeah, so I noticed in the Hiera lookup, you're essentially just calling for a specific variable. Is the behavior the same depending on the structure of that variable that comes back in the response? Like, does it know if it's a dict or an array, or and it's iterating over it there? I know.
Sure.
In that package.
Yeah, sure. Okay. So the question was, you're doing Hiera lookup on a key, and sometimes you're getting a hash, sometimes you're getting a string, sometimes you're getting an array. What's going on there? And so the answer is that there are actually a family of Hiera lookup functions, and one of them is just the main Hiera one. This is the beginner talk, so that's what we focused on. But there's also Hiera array and Hiera hash, and those will force arrays and hashes to be returned. And there's another kind of an advanced behavior that you can use where it will not abort at first match. You can ask for an array, and it will, from the first hierarchy, populate values, and then at the second level, it'll populate more values, and at the third level, it'll populate more values. So you get this merged array, which is a powerful thing that people have been using for like inherited roles. So like, you know, Drupal server is part of PHP server, which is part of web server. And at each level of the hierarchy, they get new configuration values. Great question. Are there any other questions? Yeah.
How do you go about, or what's your best way of instituting a package install that you install on but the specific node doesn't want?
Okay, the question was the inverse of a merge, which is you have 30 packages in common, and you would like one to not be there on a specific node, and you have Hiera. What do? I don't have the answer to that. Somebody else might. Do you guys? Okay, the two experts don't know either, so I'm cool. Yeah, we can talk after about this. There's a couple hacks. Just one more. This guy.
Oh, I was just going to offer an answer to that question.
Okay.
You can make an array where the keys are the package names and the values are true or false, and override just the value doing a Hiera hash lookup. And then you take out the values whose keys are false, and then get the keys with a standard lib lookup, and just install the keys.
Lookup table.
Yeah, you could do that. It can be done. We do what we can because we must. Anything else? Thank you very much. You've been a wonderful audience.